On the previous lesson, we worked with envelopes and paper to model functions with parameters and return values. Make sure you answered the Google Classroom question from yesterday. Today's lesson is in Unit 7, Lesson 2 in Code.org, Parameters and Return Investigate. Let's review that lesson. We had a function called makeCake, and it had two parameters, tiers and flavor, and this helped simplify our code. So in our example from yesterday, when we made cake, we had tiers and flavor. We repeated the tiers value multiple times, and we gave a value to flavor, which was lemon or strawberry or chocolate, and then we assembled the layers, how many we had, into a cake and put into a box. And this whole feature was a function. For this lesson, you need to go to Unit 7, Lesson 2. We're going to look through a number cruncher. So in this app, we have 3 on events because we have 3 buttons on the screen. When we put a number into the box, now we have to click a button to trigger an event. If we do plus, we get an equation here and some text. Let's look at where this is coming from. When the on event button of add button is clicked, it sets the text to an output label. It returns a calculate function. This function is down here, and we'll look at it in just a minute. If we had chosen the minus button, it would have done the same thing, but it was calculating and giving the numbers in subtraction. And the same thing for this was multiplication. They're all calling a function that is included in the program. Now let's look at the function. The function is called calculate, and it's based on a symbol that was clicked on an on event. We have 2 variables that are created by the user. They're getting the number, which is called the input number for this square and this square. It's going to create a new variable called answer based on these. It's going to run an if-else statement. If the symbol that was clicked was the plus, then that answer variable is going to be the sum of 1 and 2 from these boxes. If the plus was not true and it was minus, it's going to take number 1 and number 2 and subtract them together. If that condition was not met, then it has to be the multiplication that is true. Either way, we're getting an answer variable here to use later in the function. I'm going to skip this part for just a second and go down to the answer variable again. This is not a new variable because we called it new up here, and now we're using it at least 4 times. The answer is going to be a string that's written out over here. It's going to take number 1 and whatever the user used, plus the symbol that the user clicked. The value of number 2 is going to go here. It's going to have an equal sign, and it's going to spit out an answer that was factored from up here. This answer is going to change. It's going to set the text from input 1 and input 2 and return an answer, which appears here. Now that you understand that, let's talk about this sentence here. This is another Boolean statement that's going on here. It's taking the value of the answer variable that's figured here, and it's dividing it by 2. A mod operator divides something. If that answer divided by 2 gets the value of 0, meaning there's no remainders, it's going to be an even number. What that will do is it will take an odd name label, which appears here, although we can see it here in the design code, it's the output label, and it's going to set the text to a string. This answer is an even number. If this answer was something other than 0, that means the answer is not divisible by 2. There's something remaining over. That means it's odd. It's not equally divided. That means it's going to set that text of the odd label to the answer is an odd number as a string. So let's try it with an even number. If we have 3 plus 3, our answer is 6. 6 divided by 2 is 3, and there are no remainders left. That means it's an even number, and this is functioning correctly here. So let's go back to our slides. The calculate function is calling 2 numbers that are user input here into a text input. There's on events triggered by these buttons. In this function, it's getting the new variables. It's going through an if-else statement to see if a condition is true. It's giving you an answer. It's typing out this answer in this area, which is taking strings and user input boxes. It's changing the text, and it's returning a function. So what is a parameter? This is a symbol, these here. The argument is number 1 and number 2 with this symbol, which has created an equation. And what is returned is an answer. A quick discussion on what's a mod. You're familiar with the 4 basic math functions: add, subtract, multiply, and divide. And if we were to do a sample equation, here are the correct answers. Now, if we were to do 3 mod 2, which is how this is read, we have something left over. 3 is not divided by 2 equally. There's something left over, so there's 1. So it would be 3 mod 2, 1. Mod is the remainder that is left over. So let's practice. This really means 17 divided by 5, which we know it goes in there at least 3 times, and we're going to have a remainder. So we would say 3 remainder 2. Why is this useful? A common language is used to determine if a number is even or odd. If you divide any number by 2 and there is no remainder, the number is even. You can use mod to determine if a number is divisible by another number. Now let's look at the next app. It's a word game helper. And this app is a word game helper. You select a word length and the first letter. So if we choose 4 and words that start with A, it displays in this box. What is happening here is we have a data set with words. We had created a variable word list and we got the column of words and a word. And we're creating an empty list based on something below. We're calling the filter function to get the drop-down length from the user and get the text and set everything to lowercase. When the on event is triggered by this drop-down and it's changed, it's getting the drop-down, the lowercase, and running this function. It's also happening for this one where I choose a letter from this drop-down to run a function too. So let's look at the function. This filter function is based on the parameters of the length and the letter. It's showing an element called a waiting image. There was a hourglass here, and it's showing that it was unclickable at the time because it was waiting for me to change something here. When that happens, this list is going to be created, and it's going to set that output to whatever that list becomes. What is happening is a loop that's going through the entire list, and for each time it goes through, it's looking for the word list to be matching what we put for length, so the number of letters in the word. It's changing the substring to a letter, and it's appending that new word that fits this criteria into this empty list that we created. If the word list length is 0, so for example, if we wanted all the words that start with Q that only have one letter, there is nothing available in the English language. Default here is no options available. That will append to the list and display in the area. And while this is happening, there's a waiting image, and it's unclickable in this box. And then it's going to set the output to the filtered word list and create it here. So once again, we have variables that we created. We're using a data set to pull the information. We have 2 on events that are actually drop-down menus. Those trigger some filters to run. We have a filter that's running parameters based on length and letter. It's showing elements on the screen or hiding elements on the screen. And based on what the user put in the drop-down menu, it's going to go through a Boolean. While it's looping through this, it's adding stuff to our empty list. If nothing matches that, there will be something that says no options available, and things may be hidden. So what we're learning today is that extracting shared features to generalize functionality is known as procedural abstraction. Using parameters allows the functions, which are also called procedures, to be generalized. Using the procedural abstraction helps improve code readability. We had a lot less code because we could simply have a function calling that function based on variables. The procedural abstraction manages complexity by allowing for code reuse. You could take this function and use it elsewhere and just call it. For example, the function move, which would be based on an ID and a direction, could be used to move an element in any direction, rather than writing separate functions for each direction. And that would be a lot. So your assignment today is to modify the Word app to have included 8 and 9 letter length options of words. So what you'll need to do is change your app to design mode and edit the drop-down menu. When you're done with that and your function works and shows words that are 8 and 9 letters long based on certain letters, copy and paste your public link in a private comment in Google Classroom.